I'm going to talk today about what is called a common ground and differential diagnosis, which is a concept from medicine. I have some theory and a little bit of software that will make your teams much more effective at troubleshooting. These are all my social media thingies. I'm on there. Right, so we've all been on teams where something's going on, you can't figure out what it is, and everybody's racing around trying to figure it out at the same time. And sometimes you can get running around in circles, you can get stuck, you can not know who's working on what. And these are very expensive problems. So group troubleshooting, if it's going to happen well, depends on very effective communication so everybody is in the same place on the issue. And I'm going to show how if you know the theory behind, if you understand where you need to put your automation, it can be very effective. But you have to know why you're doing it. All right, so common ground. Common ground is a concept that has come out of ergonomics teamwork research in the last few years. And it's this idea that, that when people are doing joint activity, working on the same project together, they need to have some sort of shared state of mind so that they, when they use language to update each other's model of the world, they can interpret it correctly. Everybody knows what the words mean that are being said, and nobody sort of goes off and gets lost in their own world because they're making incorrect inferences. So the paper that this stuff all came out in, which I'll have a link to later, defines common ground as pertinent knowledge, beliefs, and assumptions that are shared among the involved parties. And that includes goals, and that includes understanding of why you're solving the problem you're solving and how you're solving it. And we use language to maintain and achieve that common ground, to update each other's model of the world, to make sure that everybody's on the same page. So we're going to do something really fun. We're going to just murder a joke by analyzing it. And that's how you kill a joke. So this is a tweet. If you can't see it that clearly, it has a drop-down list with the choices male, female, and inherited type class. And the tweet says, the three genders. Now, everybody in this room got this immediately. They don't need me to explain it, but I'm going to do it anyway because I want to show you how much shared context and common ground is required to tell a joke, right? So what do you need to know to understand and to tell this joke? Both the understander and the teller need to know what a drop-down list looks like. They need to know that male and female are genders among humans, right? They need to know that inherited type class is not a gender, or it could be, I guess. I don't know. My list of gender is not up to date. And that inherited type class is a programming term, so this probably happened because of a software bug, and you can imagine exactly how it happened, right? This person's intentionally misunderstanding what happened here for humor. Get it? It's a good joke, right? Okay, so my point here is that there's a lot of shared context that we take for granted when we're talking to each other and when we're trying to communicate information. And if that context gets out of whack, then we can't have effective communication anymore. And it gets out of whack when the situation is changing very fast. So the main way that we lose common ground when we're doing joint activity is called the fundamental common ground breakdown. There's a link down there to the paper that is about all this, got these ideas out there. Great paper, go read it. It's pretty long, but definitely worth reading. I'll post my slides on Twitter later, so you can have that link. So here's how it works. Alice believes Bob has some knowledge. For example, Alice believes Bob knows that you're not supposed to commit secret keys to the Git repository. Okay? Bob doesn't have that knowledge. He's new, he's never worked on this kind of software before, he doesn't know these things. So he doesn't even know that he's supposed to know something, right? So if he knew that there was information he needed, he could ask Alice, but he doesn't. So he just goes on doing his job, doesn't ask for the information, and what does that tell Alice? Well, since he's not asking anything, Alice says, well, he must know, right? So I don't have to worry about it. I'm more confident now that Bob already knows this. And you get into this cycle where the common ground breaks down more and more, and they start making inferences on their own different models of the world, and at some point you have a coordination surprise. These are bad. So in our case, in our example, the coordination surprise would probably take the form of Alice being super angry at Bob for committing secret keys to all the Git repositories, and now they have to go change all the key pairs or run BFG on all the repos, and it's terrible. The fundamental common ground breakdown happens all the time, and it's super expensive. It costs us in the time that we waste on bad assumptions that we end up being wrong about. It costs us in the time we spend repairing breakdowns after they happen, getting rid of all the keys from the repo, for example. And it costs us in trust. We can no longer have confidence that the words that we're saying to our coworkers will be understood in the way they were intended. It makes us more cautious about things. It makes it harder to communicate. So we want to try to avoid this as much as we can. And as you grow your team, it gets worse and worse. It gets, I think, quadratically worse with the number of pairs of people who have to maintain shared state on your team. So what can we do about it? Well, first of all, let's think about how this concept shows up when you're doing troubleshooting, when you're all in a chat room, trying to figure out what the hell is up with the servers. It happens in a chat room usually these days, and chat rooms are great. We all love all the ChatOps stuff. Chat rooms are good because you can get immediate feedback if you have a question or a concern or something. Everybody can get in there and see it and contribute, and you will have a persistent history. So you can always go back and look, I remember this happened one time, what was that about? You can go back in the history and look at it, or if you show up in the room and you're not sure what's going on, you can read the history to try to figure out what's going on. So don't get me wrong, I'm a big fan of ChatOps, but I do have some criticism of this approach for troubleshooting, and I think we can fix the problems that I'm identifying. Because you've got all sorts of people in the chat room who can contribute different pieces of information. You got ops, they know what the system is doing now. You've got devs who know what the system's supposed to be doing. You've got, and a lot of people ignore this, but I really like to have account managers, product managers, support reps in the room helping out. They can help you prioritize the problems that are biggest for the customer and translate things into customer terms. I think that's super important. And whatever, QA engineers, sure. So, but what you end up with is, is you have a team of experts, each of whom is really good at the thing that they're supposed to be good at, and they communicate effectively because they share a goal and they share knowledge of the world in which this problem is taking place. And they share understanding of the current state. Why are we doing this? And how are we doing it? And who's responsible for what? But here's the problem with chat. So when you're solving problems in chat, it's very, very easy for common ground to break down. It can break down for a lot of reasons. It can break down because one person who's super technical said something that all the other technical people were immediately like, oh, of course. But the non-technical people won't get it, and their mental state won't change with everyone else's. It can break down because people are busy. If they're not really concentrating on what's going on in the chat room, then they're going to lose track of what everybody's doing and why. If two people turn to each other and have a conversation face-to-face, or they call each other, that stuff's not going to show up in the chat room. And that's useful to do because it's super information dense, but it's not going to be in the chat, so you can't use it in the chat. And sometimes people show up late, right? They haven't been working the problem. They don't know the whole history of this issue, and they don't know what's up when they show up. So what do we do when people need to know what's going on and they haven't been able to keep up with the state of the problem? Well, one thing we do is we tell them, here's what you missed, right? We give them a summary. That kind of works, but it takes time away from the person who's giving the summary, and it's a little broken because the person who's asking what's going on, they may not know what information they're missing. They have unknown unknowns. And the person giving them that information, they might not know what questions they should be answering. Since they have a common ground breakdown, they may not know like what needs to be done to repair this common ground between them. And the other thing we do is we tell people to read the backlog, which I have a play, and I'm going to invite the the differential diagnosis players up on the stage. Everybody give them a round of hands. We have Dominique Whitaker as Beverly Crusher. We have Alex White as Alyssa Ogawa. Scott Bauer as Worf. Lori Dennis as Data. We have Ryan France as Jordy. And we have Catherine Beerops as as Riker. You're Riker, right? Yeah. Okay. So have microphones for them. Bloop, bloop, doop, doop, doop. Okay. So you're going to have to pass these around as you go. And here is a chat session that happened among the Enterprise Bridge crew one day in HipChat.
I reconfigured the quantum phase allometer.
Okay, checking the molecular signature.
Hey guys, what's the ETA on that neurocomposite? Jean-Luc's on the phone with the Bajorans and they're getting anxious.
About 20 minutes.
Approximately 22.684 minutes.
Jordy, wait, I don't see your allometer readings in the logs.
Oh crap, hold on. I forgot to account for the orbital decomposition.
Okay.
I just received a security alert from the biomedical lab. Should I send a team?
Whoops, that was me. False alarm.
Did you accidentally depressurize the nanofluid inhibitors?
No, I meant to depressurize them, just forgot I set an alarm to such a low pathogen threshold.
Okay, Crushinator, I got the allometer readings. Check the logs again.
Got it. So we know that this is a problem with the interference spectrochrometer.
Okay. Okay. Thank you guys. So that was a little story about solving a problem. A lot went on that may not have had to do with the problem that was actually being solved. So we're going to go back through this little interaction we had, and we're going to talk about some things that you would have to deal with when you're reading the backlog that would make it really hard to get back on state with this problem. So guys, go ahead.
I reconfigured the quantum phase allometer.
Okay, checking the molecular signature.
Hey guys, what's the ETA on that neurocomposite? Jean-Luc's on the phone with the Bajorans and he's getting anxious.
Okay, that right there, that was a status request that wasn't really relevant to the problem that you're trying to figure out. It had to be in the chat room. Chat rooms are great for real-time stuff, but you don't need to read that when you're going back and checking the status.
About 20 minutes.
Approximately 22.684 minutes.
Yeah, okay. Conflicting information that's redundant. You don't need to read that piece of information twice, and you're also going to have to spend some time figuring out, wait, why was that there? There are two things there. I need to understand that.
Jordy, wait, I don't see your allometer readings in the logs.
Oh crap, hold on. I forgot to account for the orbital decomposition.
That invalidated some previous information that had already been given by Jordy. So everything you already read by Jordy from before that in the chat log, you don't need it anymore.
Okay.
Okay, that's a confirmation. That's a real-time confirmation. That's useful in real time, but it's not useful when you're reading the logs.
I just received a security alert from the biomedical lab. Should I send a team?
Whoops, that was me. False alarm.
Okay, that turns out was completely irrelevant. They thought it was irrelevant at the time, but it doesn't help you when you're trying to rebuild your state.
Did you accidentally depressurize the nanofluid inhibitors?
No, I meant to depressurize them. Just forgot I set an alarm to such a low pathogen threshold.
Yeah, again, not really relevant to the spectrochronometer problem. It's a different thread. You don't need to know about it.
Ah.
Okay, Crushinator, I got the alarmometer readings. Check the logs again.
Got it. So we know this is a problem with the interference spectrochronometer.
And those last two lines are really the only things you need if you want to know about the current state. You don't need that whole backlog. Those last two lines tell you exactly what you need to know. Thanks, everybody. Thanks so much. Great job. So that was only 18 messages. Imagine a 100 or 200 line long backlog you have to read. It's gonna take forever, and you're gonna be up against all sorts of irrelevant stuff that you don't need to know about. So that's why chat rooms are great for updating Common Ground in real time, but they're not so great for maintaining it, repairing it when it breaks, and we can come up with a better system for this. So the better system that I want to talk about today is called differential diagnosis. So this is a thing for medicine, and I have used it a bunch of times in the last 4 years since I learned about it at Velocity 2012 from Steve Bennett. And it is a sort of a formal way that doctors solve problems that are complicated and tricky. This is what House does when he gets everybody in the room and they're all writing on the whiteboards and he's making fun of them for coming up with stupid ideas that turn out to be right. You don't have to do all of that, but it's fun. So it's a formalism around medical reasoning used by doctors. Now, doctors are a team of experts with a diverse set of expertises, and they are working together to understand what's going wrong in a complex system, which is what we do, right? So we can learn a lot from how doctors solve problems. I like to explore those analogies. So how does DDX work? DDX is short for differential diagnosis. Step one, you write up, you get in a room with a bunch of clean whiteboards, and you pick one of the whiteboards and you say, okay, here we're going to write up the symptoms that we know about for this problem. What do we see going wrong? What do we see not going wrong, but should be in this case? Anything that's weird that you need to know about to debug the problem, just make a big list and brainstorm. Once you have all the symptoms down that you care to write down, you start to brainstorm things that could be wrong, hypotheses, which doctors call differentials. You say, okay, looking at these symptoms, what does all this add up to? Could it be lupus? Could it be, it's probably not lupus, especially in tech. It could be server lupus. But you write down, you brainstorm, no bad ideas in brainstorming, and this is why I like to get a lot of different people from different parts of the company in the room to do this. You just write down all the things that you think might be wrong with the system. And then you say, okay, well, which of those hypotheses is the scariest? Or which is the most likely? Or which is the easiest to test for? You just pick one, and you say, what test can we perform to see whether that's true or see whether that's false? And you go and you do the tests, and you come back and either you were right or maybe right, and you keep going on that hypothesis, or you disprove it, and you can cross it off the list and go back to the beginning, and now you're one step closer to solving this complicated, tricky problem. So I'll give you an example. My coworker, Andrew, volunteered to have his photo in here. So Andrew was in HipChat, and he just typed a bunch of nonsense, blah, 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 right? And then he fell out of his chair, and then his mouth started foaming. So, so everybody gathers around Andrew and like puts their hand on their chin and goes, yeah, what's that about? So we might say, these are our symptoms, these 3 things that we noticed were wrong. And then we say, what could be wrong here? Well, he might have food poisoning, extreme food poisoning. He might be faking it to get attention because he's kind of an asshole. This isn't going to be on YouTube, so I can say that. Or maybe he has rabies, right? These are 3 hypotheses that could explain all this weird stuff that's happening. So how can we do a test? Well, we can say, did anybody here have the same thing as Andrew for lunch? And if they don't have food poisoning, then it's probably not food poisoning. We go through that and we say, yeah, Maggie had the same thing. They both had the fish, and they're not, Maggie's not sick. So we can't say it's definitely not food poisoning, but we can say it can move down the list, right? It cannot be our priority anymore to investigate. And we can go back to the beginning and go look for some more answers. And the cool thing about this procedure is that it never, so in medicine, it can, like the patient can die before you finish it. But in tech, in servers, like it always leads to an answer. If you follow this procedure, you're not gonna end up running around in circles, you're not gonna end up forgetting what you've already tried. It will deterministically get you to the answer if you iterate. So you just repeat until you have the answer. And so here's the thing that I think can fix troubleshooting in chats and make it way, way easier to fix problems. We can use differential diagnosis as an engine for keeping track of what everybody knows about the problem in the chat room. And that avoids a lot of problems that we have with troubleshooting in chats now. It avoids having people to go read the backlog, right? If we have a big whiteboard with all the stuff written on it and our current state of the problem, we don't need to go read the backlog. We can just look at the board and see exactly where we are. We won't retread things that we've already tried because they're there. They're crossed out on the board. You can just point to it and say, we already tried that. We don't have to recap the current status for people who weren't in there when the problem happened. We won't lose track of who's doing what because we can write people's names next to who's doing the testing for a particular hypothesis. And this is the part that's really important for me. Everybody's following the same problem-solving strategy. You know, it's a little formal and maybe a little cumbersome for small problems, but if it's really confusing, you can avoid all of this people thematic vagabonding and going off on their own and trying to solve the problem a different way by having a structured problem-solving strategy. So the important thing about DDX in a chat room is that you've got all this information going by, and some of it's important and some of it's not. Differential diagnosis lets you say, that piece of information, I want to promote that to group knowledge, and it can stick there in everybody's mind. So I'm going to show you a little HipChat bot that I wrote, or HipChat, a WhoBot plugin that I wrote that helps solve this problem in HipChat. So here's my HipChat chat room where I'm doing differential diagnosis. I posted some cat breadings to clear out the backlog. I love these. Cats are hilarious. So let's say there's an emergency. We're in the chat room. We're trying to solve the problem. And we decide, OK, we're going to use DDX now. This is complicated enough that we need a structure. So somebody in the chat room says, DDX start. And they describe the problem. The problem is Souls is, sorry, that's Andrew's last name. Andrew is acting weird. OK. And the bot in here, once he wakes up, because it's running on a tiny, tiny Heroku thingy, the bot will say, OK, you want to do differential diagnosis. We're going to create a board for that that everybody in the chat room can see. And then it'll be in the chat topic so that everybody can say, oh, just go look at the board. I don't know why it's not working, probably because this is a live demo. Wow, brutal. Okay, well, I'll show you what it looks like. Yeah, I don't think we quite have time to do that, but I have a backup plan. Yeah, I have a backup plan. Oh, except I have no internet connection. Yes, I do. There we go. Okay, so somebody in the chat room will say, yeah, I don't know why that's not working. All right, somebody in the chat room will say, I have a symptom to report. The quantum wiggler is showing reduced wiggliness. And they'll just type GDX symptom quantum wiggler, blah, blah, blah. And that will show up here on the Trello board. Has a little ID that you can use to identify it to the bot. And so on for other things in the list. You can post pictures in it. Since it's Trello, you can post links to stuff. You can post comments on things. And now this board is in the chat and is in the chat topic, and everybody can go click on it. Then you can start putting up your hypotheses. So you can just type out, here's what I think. This just flows into the natural discussion inside your chat room. As soon as somebody has an idea that they might want to test, they type out, this is a hypothesis, bam, it shows up on the board, and then you can create tests that you are working on too. You can assign the test to people, and when you do a test and you're done with it, you can say, I'm finished with this test in the chat room, and it will label that test as finished. And you can say, okay, we just disproved that hypothesis, so it'll label the hypothesis as already tested, and it'll move down to the bottom of the list. And so this board, I've used it a bunch of times to solve complicated problems, and it's super, super useful to have a link that you can send to anybody, any level of technical expertise, anybody who needs to know what the current status of the problem is. The most important stuff is all here. We know who's working on what, we know why. It's really nicely encapsulated. Did it start working? No? Okay. So that's up on GitHub. It's on, I'll put a link in my slides when I send them out. So that it's hooks in with Whobot right now, but I'd like to see a Slack implementation of it or whatever the cool kids are using now for chat. And you can also use it to make food orders, which some of my coworkers have abused this system to put their food orders in the chat room, and their food orders showed up as symptoms, which is philosophically interesting. So I have some final things that I want to point out about this stuff. One of the major problems, so like I said, I've done this process a lot of times, and it works great. But there's a little bit of a hitch when it comes to switching from like random problem investigation mode, where you think you might be able to get it fixed quickly, to differential diagnosis, formal problem solving, rational mode. So when does your team flip over from normal, this is a problem type behavior to differential diagnosis? I don't have a good answer for that yet. If anybody has some ideas about that, I'd love to talk about it. And you can learn more about differential diagnosis. I highly recommend you do. I have office hours at 3 in the exhibit area, so you can come talk to me about it there. Also, Steve Bennett's 2012 differential diagnosis talk. The slides are up there on that link. I would really wish that talk were on YouTube, but it's not, so maybe you can dig up the old DVDs from Velocity 2012 and find it. He goes into a lot more detail about how you choose which problem you want to investigate at which time, and the different approaches for that, which is great stuff. And I have a blog post about this called "You Know Who's Smart? Friggin' Doctor's Man," that is about a particular example of a time when I used this process and how it went well, and how you can do it too. So thank you for listening to my stuff about medical reasoning and ergonomics theory and a bunch of windbaggery about all this stuff. And I would like to know if anybody wants to give me a question about it, or you can, yeah, come on. Yeah. Them, really, they're the stars. Yeah, go, please,
Okay.
please.
In differential diagnosis steps, you listed performing tests to falsify assumptions. Are you borrowing that from medicine? And in tech, are we only trying to falsify assumptions, or in some cases, are we trying to validate them? Not assumptions, but hypotheses.
Yeah, that's a great question. So in differential diagnosis, when it's formally presented, one is supposed to try to falsify their hypotheses rather than try to confirm them. When you are trying to confirm your hypothesis, you end up in you can end up in a logical fallacy situation called affirming the consequent or something. The idea is that if you have a idea and you're really trying to prove that that's the case, it's easy to run a bunch of tests to think where you still think maybe it's the case, but you can't really prove it until you fix that problem that you think it is. If you disprove other things on the list, then you can adjust which hypothesis you think is most important as you go, and other things tend to fall off by process of elimination, and you're left with the one that you're pretty sure about. Yeah, go ahead.
I think I enjoy DDX just for that reason, because you like being able to prove people wrong. But my question is what happens when you don't get all the hypotheses? You said you always come up with an answer, and I'm thinking of a recent case that we went through, and the possible hypothesis was so harebrained it didn't make the first cut, and it wasn't until 2 or 3 passes later, after we had pretty much exhausted every possible item, that we'd like, okay, now we need to go back, restock the hypotheses. Is there a way that you recommend to try and get all that out the first time without being too burdensome and listing out, okay, the moon exploded, sunspots?
That's a great question, and I know exactly the kinds of situations you're thinking of, because I've had it happen a few times where what is actually wrong is just so dumb and nobody thinks of it. But there's 3 important things. You've got to make sure you have plenty of different kinds of people in the room, people with different points of view, so that and 2, you got to make sure that you don't discourage anybody from writing anything down, even if it's kind of silly. It's brainstorming. You really got to get all the ideas up on the board. And 3, it's a cycle. So you come back, you test some more hypotheses, and when you have run out, you come up with more, because something's wrong. So you either bring something back from the dead and say, well, maybe you're not quite sure about that one, let's try it again, or you come up with something new, because you know that there's a problem. You just need to think of it and keep trying, and eventually you'll get there. Yeah, please.
So I definitely want to try DDX. I'm concerned that there's going to be pushback when, at which point do you switch gears into this and avoid having, like, what if there is an incident and there's really only 1 or 2 options, and they would have solved it much more quickly if they hadn't gone to the whole sort of heavier process? Yeah.
Thanks. That is definitely an issue that I've tried to use DDX on problems that were too simple to even bother. But what I would recommend is the first time or two you use it, pick a problem where people are already kind of spinning their wheels. Pick a problem where you can see like, oh, we already tried, like we tried that, or I don't remember what we tried, or I don't know, I'm blocked, I can't think of anything else to try. Then you can demonstrate the value of differential diagnosis on a problem that is already, and that may be too late, like maybe you should have started sooner, but at least from that point on, you'll have a single procedure that everybody can follow and they'll deterministically get to an answer.
And
That's what I'd recommend.
Have you ever tried having a point person who's not allowed to look at the charts, not allowed to go researching their own favorite hypothesis, so that they're an unbiased party just listening to the ideas and recording everything? Because I'm thinking, hoping that that might help decide when the turning point is where they say, okay, let's go, you know, you are assigned to this test, you are assigned to that test. And one of the things that happens at my company a lot is that individual contributors go off and try stuff, and they aren't just looking at that point. They're changing things in production without a ticket.
That is, thank you. That's a great idea. It's sort of like a combination 12th man and like overview, somebody with an overview of the problem. I think that's a great idea. I haven't tried it, but now I kind of want to. So thank you. I have time for one more question. So I think.
It seems like you could do a DDX session in two ways. One where you have like a chatbot facilitating and everyone kind of self-manages, or having a house-style figure who's running it and aggregating things. Do you find that one works better than the other, or whether you need a leader or you can kind of self-manage?
Thanks. Yeah, good question. I've never tried actually having the chat bot orchestrate and make sure that people are doing it the right way. I feel good about it being a human-driven process. Humans are very good at abstract thinking and figuring out when they need the tool and ignoring it when they don't. So I try to avoid tools that force themselves in any way on the people who are using them. It works as a human-driven process, either in person or in chat, and I don't want to mess with a good thing. Okay. Well, thanks everybody for coming. I hope you learned something and enjoyed it, and come to my office hours at 3, and also rate my talk.